Hello. First of all, thank you very much for the opportunity for us to listen, learn, and present at the OpenBMC and AMI and Meta OpenBMC Meetup. My name is Thiru, and I lead the overall Azure Control Plane Firmware Engineering organization. BMC happens to be a part of that org, and I'm co-presenting this session with my architect Dhananjay. And also I have our PM lead Karim, who is sitting in front of us. So I'm going to talk about what aspects of the hyperscaler and the challenges, and of course Dhananjay will delve a little bit deeper into those aspects. So first of all, let me start with a little bit about the scale, right, at which we are talking. So we're kind of deploying millions of nodes, and most of the nodes have either one or multiple BMCs. What does that scale mean for us, right? So when we have few millions of BMCs that we are deploying, that with various diversity vectors like hundreds of platforms and hundreds of SKUs, which are more like derivatives on top of the platforms. First, the BMCs are collecting a lot of data from every peripheral or the CPU or anything that it connects to. And then we have to push all of that data and harvest the data to generate the insights. At the same time, we also have to accommodate different product group requirements that come to us. So we need to harvest the data. At this scale, if an error can happen, it will happen. So that means BMC have to have solid error handling, and also it needs to have the availability at the highest level. The reason is a BMC that is not available will not be useful, that is unresponsive will not be useful for our use cases. So one of the main use cases is we use BMCs for example, to bring the nodes back to like productization, right? So as part of that path, we'll have to first figure out why a node or a server is not available. So for that, we need telemetry from the BMCs, and we need to use that telemetry to identify and narrow down the issue and then also perform like repair actions. So at the same time, BMCs themselves have a lot of security fixes, feature enhancements, and etc. So we need to deploy those fixes at this scale. So our deployment velocity and yield has to be very high so that the BMCs have the latest and greatest firmware. I'll hand it over to Dhananjay to talk about the next steps.
I hope you can hear me. So I lead the OpenBMC adoption in Microsoft and some of the security investments we are doing to help around BMCs. I mean, traditionally BMC security has been a little bit weak spot because BMCs are managing hardware, and they are also running a lot of protocol stack in everything, including web servers. So my tenure with BMC is actually pretty short, like 4 to 5 years. So I come with a fresh perspective of what is possible and where open source helps and etc. So like Thiru mentioned, we have a lot of variety on hardware and its usage, compute versus storage, and a lot of variety in terms of what this stack runs on, like number of A-speed chips and now Neoton and maybe tomorrow something else. On the host side, all sort of host hardware available. Microsoft has it in the fleet, whether it's Intel, AMD, NVIDIA, and a lot of other things. A lot of NICs, storage devices. So there's no shortage of. I would say we can check every box on hardware, and we have it, and that also makes our development for BMC quite challenging. And last 3 or 4 years, I have been focusing on how we can do this at scale, because it's not only the hardware that is the challenge, but also the API requirements from our internal partners like compute, etc. Right? I mean, they are looking to manage these devices and servers and whatnot. So we took a fresh approach of looking at OpenBMC, just similar to how people use Linux kernel. It comes with a lot of features and something we enable to suit our requirements, both in terms of functional features as well as whatever security features are available. And our goal was to have maximum common code across all of the platforms we are supporting, right? So a good example of that is, we are fixing some CVs. We don't want to port it to like different, DevOps projects and etc. We want to have like as much as common, right? Now, a bunch of this is actually done by the community. To be honest, I mean, like we are not looking at fixing CVs ourselves. I mean, we are making sure we are syncing whatever Yocto and elsewhere we find. If those are like private disclosures, we obviously are open to stage patches in our tree. And one of the thing I would like to mention that forking or having upstream and downstream trees isn't necessarily a problem, because the downstream trees are actually serving its usage, right? And there are constraints on how it gets built. For example, all of our source gets built in Azure DevOps. I have worked in the past with Jenkins and etc. But Microsoft requirement is, we build everything in Azure DevOps. And Azure DevOps is actually quite a good integrated solution. It not only provides, source control, work management, test case management, but it also has a very neat infrastructure for, build pipelines and a lot of other things, right? For example, one of the challenge has been, how do we make sure whatever we are building, and if there are any security fixes, they are being tracked, right, at organizational goals or OKRs. So Azure DevOps provides a lot of these things, like on top of Azure DevOps that is publicly available. Microsoft has a very large engineering systems organization which is managing security around all the DevOps and what gets built, and monitoring. Like, so for example, they maintain like latest patched virtual machines or container or build containers. They are also providing infrastructure for isolating build VMs or containers, right? I mean, we utilize network offline builds from the beginning, because for all our production code, if we are fetching everything from web, I mean, there is a supply chain issue, like something goes off, or there's also stability issue, right? I mean, some of those mirrors and etc. Become inaccessible, and we don't want to be broken, because we are building like thousands of times every month, and so many platforms, hundreds of platforms we want to support. So this provides us a great way to have like a secure and stable build. And this is where the Azure DevOps infrastructure comes into picture, right? I mean, we have build VMs, pipelines, and the isolation, and the performance management, whatever caching is required, like Yocto is a very heavy build system. So we have created internal caches that make things good. Now, one of the inflection point is like as we work with the community, we obviously cannot take any binaries that are compiled elsewhere. That's a non-starter for Azure, right? I mean, we care about security so much that we want source, and if it's not open source, we are happy to take closed source through NDA agreements. But we want to build from source, right? I mean, The second aspect of it is as we build, we produce like full SBOM, and that SBOM is monitored centrally through our Azure DevOps organization. They are looking what different teams are compiling. They maintain like a full database of what goes on. So in addition, I mean, they help us to since we are consuming some NDA source, right? We want to make sure we are not going into the licensing issues. We want to maintain good isolation between what we get from IHVs, right? I mean, we don't want to mix up things. So they provide like a very fine-grained access control on our repositories, build pipelines, etc. Right? So that only people who are say working with NVIDIA or Intel, etc., get access to those build pipelines, etc. It's not like visible. But a lot of our code is just common, right? I mean, and when I say like common code, it's just taking whatever upstream OpenBMC is and whatever modifications we need for our control plane, right? I mean, which is making API calls into BMCs. They are typically Microsoft specific, right? I mean, so even that we try to keep common, right? Because that is how the manageability at scale can happen, right? If we support same APIs on different SKUs and platforms. But we do maintain like the last level isolation between different IHV sources, right? So that we don't mix licensing and etc. As Thiru mentioned, like we are looking to scale observability, and this is from both like the hardware telemetry as well as security, because you can imagine for Microsoft or Azure, if there's a compromise, it's going to create like a big issue. So we want to make sure whoever is getting privileged accesses to BMC, etc. We have like a full oversight on what is going on in the data center, right? Through software, and we collect a lot of telemetry, and we are building sort of building insights, either through existing infrastructure that Azure already had, or using AI. And I did mention AI integration. That is another place where the centralized infrastructure, DevOps infrastructure helps us, right? Since we collect so much telemetry, we want to make sure we have a good inferencing on not only hardware issues or whatever patterns, but also any access patterns, like someone who is not supposed to access or doesn't have like privileges, or JIT tokens generated is trying to access, and those kind of things, right? I mean, we are looking at all of those things. And to add to like what we are doing with AI, obviously code generation has become cheap, right? I mean, it's not like 2023, I would say, where you had some spec and you have to write a lot of code, and it can generate, right? I mean, if the spec is decent and clear instructions. We also use it for test case generation, right? As we add features, we are looking at using it for doing security scans. Again, these things are really easy and cheap now. Like you can unleash some of these models, LLMs on the entire code base. But we are conscious that yes, there are like thousands of sources in the SBOM, right? It doesn't mean like we can fix everything within Microsoft. We want to work with the community. Like the fixes should go in the upstream, just like it happens with Linux 7, right? I mean, that is the sort of source of truth. And so we are looking to see how we can scale this. And one of the things I actually personally use at scale all these models is code reviews, right? I mean, besides all the upstream source changes that happen, we still have pretty heavy changes that we do in our downstream mostly because of our own requirements. It's not something like we are trying to create like a secret feature for kernel or etc., right? I mean, it's just making sure our manageability and observability requirements are met and things like that. So I use it at scale to do code reviews. I have put together instructions, for example, that enforce like the at the very basic coding style of kernel, coding style of OpenBMC, so that whatever we create becomes upstreamable, right, from the get-go, and we don't have to spend another few weeks to make the code upstreamable, right? I mean that is one of the things. Lastly, all of this diversity and whatever infrastructure has to come together in terms of platform agility, right? Ever since we started like 3 or 4 years back, every year like tens of different platforms come up, because there's always some new innovation happening in the industry, and we want to make sure we have a platform or SKU for that. And we wanted to make sure we reduce the time it takes to support it in our common source or whatever infrastructure. And this is another place where AI is helping, right? I mean, like we analyze what the platform should do, and that window of initial bring up is quite it's like weeks, right? I mean, just if you take a new host hardware and unknown BMC chip, it doesn't take much as to spawn like a workable build that can be used for platform build, right? Obviously these platforms have some new hardware features that we have to support in terms of monitoring and etc. So that happens, but just getting a workable build isn't a problem anymore, right? There are other things that we care a lot, because we have multi-sourcing on some of the hardware components, so we make sure they are supported from the same code base or same image, so that we don't have to redeploy things like that. Again, here open source helps quite a bit, especially kernel, right? I mean, which is essentially managing the hardware. And lastly, we are also looking at scaling our device remediation story, because all you do, things can go wrong. You will always have some memory errors and whatever else, and so we want to speed up the device remediation and to get it faster to the production, right? So all these things matter quite a bit for Microsoft, and we are very happy, as I say, like as I have been saying, rather, the efficiency is coming from open source, and AI is helping us to accelerate, right?